All right, let's take a look at what I have here. We've been talking about standard form of a quadratic function or a quadratic equation, and this is the form that it's supposed to be in. If I put numbers in here, it could be something like f of x equals 3x squared minus 2x plus 4, right? I'm just making this up, okay? The 3 is your A, your B is -2, and your C is 4, right? And remember, C is your y-intercept. This is kind of review, okay? Now, they call it a function because it starts with the letters f of x, okay? Now, what we've been working on is equations. It's the same thing. Remember, f of x can be changed to a y. So don't get mixed up, okay? Standard form, ax squared plus bx plus c. That's what standard form is, okay? I can write it as a function if I put a letter like f of x or g of x or y of x, okay? Or if I just change this to a y, I can write an equation, a quadratic equation, okay? So if I wrote something like this, okay, there's a couple things that we could tell here. My A is a -2, my B is a 6, and my C is a -1, right? And what does A tell us? A tells us that it is a spill, right? It's going this way. Why? Because that's negative. On this problem over here, my A was a 3, so this was a fill, okay? This is all review. You guys should know this, okay? And also, my C is my y-intercept, right? Okay, so just a little review. Now, what we're going to do today, it's a little bit different, okay? What we're going to do today looks different, okay? It's called vertex form, okay? Vertex form of quadratic function, okay? So when I write something like f of x equals a, parentheses x minus h, parentheses squared, plus k, that's in vertex form. Now, this is actually kind of good. It's actually easier to do these problems that are in vertex forms, okay? And you know what we're going to do is we're going to end up graphing these. But there's certain things here that we can tell when it's in vertex form. When you look at A tells us if it's a fill or a spill. It also tells us if it's a stretch or a shrink. That's a vertical shrink. Okay? Remember, stretch in the morning. Your arms are getting closer to your head. Remember, when I used to do this in class, stretch means you get up in the morning, you stretch, and your arms go closer to your ears or your head. Shrink is when you bring your arms downward or closer to the ground, okay? Now you see this H, okay? H, I always remembered as horizontal, okay? This is the X value of the vertex. Okay? The K right here, that's your Y value of your vertex. Okay? So, if I gave you a problem that said something like this, f of x equals -3, and then I had x minus 2 squared minus 1, okay, there's certain things that I can tell you just by looking at this, okay? My vertex is this number right here. Now you got to be really careful though. You see how the minus sign is part of the formula? Okay, that's part of the formula. So we don't count that in my vertex, okay? It's just 2. And then negative 1 is my y value. See, my x value is h, my y value is k. So my vertex is 2, comma, negative 1. Where did I get those numbers from? Right here and right here, okay? Now, the next thing you can also tell about this is we know our line of symmetry. I'm just going to say line of sim, okay? My line of symmetry is x equals 2. And you say, where did you get that from? It's the x value in your vertex, okay? Let me do a couple more. It's not that hard. And by the way, today I'm going to do a 2-part video, okay? The first part is what I'm doing now, and then I'll do one later, okay? Let's take another problem, okay? Let's start with something like this. Let's say, I'm just going to make this up, okay? H of x equals 3 and then x plus 2 squared, okay? Now, this is in vertex form. I know it doesn't look like it, but it is, okay? If we go up here, remember there's a minus sign in the formula. And here I have a plus sign, okay? Now, in order to get a plus, it's basically written like this. And it's kind of confusing. And I'll give you a shortcut. It's 3 and then parentheses x minus negative 2 squared, right? Because 2 negatives make a positive. Now, you don't see anything over here, do you? Now, what's another way to write nothing in math? Plus 0, right? So this equation, this function, okay, I rewrote it to look like this to try to simplify it for you. But I'm going to give you a shortcut in a minute. So what's my vertex? My vertex in this problem is hk. H is a negative 2 and the y is a 0, right? And then my line of symmetry, and what does the line of symmetry do? It cuts the parabola in half, right? My line of symmetry is always this number right here. It's the x value of the vertex, so it's x equals negative 2. Now, what else can I tell from this equation or this function? If I look right here, that's A. A is positive, okay, and it's a 3. So if it's positive, all right, that must mean it is a fill, right? And it says 3, right? So that means that that is a stretch by a factor of 3. In other words, it's going to be narrower than the parent graph, okay? Let's do one more. If I take something like this, f of x equals 2 times x minus 5 squared plus 2. Now this one's kind of easy. And the reason why it's easy is because, see the minus sign right here? That's part of the formula, okay? My vertex is this number right here, which is 5, and then that's the H, and then this is the K right here. So 5, 2 is my vertex. And my line of symmetry, okay, is this number right here. It's x equals 5. Okay, now once again, this is a fill, and it's a stretch by a factor of 2, right? You know, our next step, what we're going to do is we're going to graph these. If I was just to kind of make this really quick over here, my vertex is at 5, 2, so I would go over to the right 5, 1, 2, 3, 4, 5, and then I would go up 2, which would be right there, right? And then, you know, I know this is a fill because A is 2, so this is a fill. So I know this is going to go up like this right here. And then this is a stretch by a factor of 2, so it's going to be a little bit narrower than, well, that's pretty bad. It's going to be narrower than the parent graph. Alrighty? So here are 2 examples. I can do one more really quick. Okay? Let's see here. Let's do one like this. P of x equals, there's a negative sign in front, x plus 3 squared plus 1. Okay? Now to get the vertex, remember I told you guys that I was going to show you a shortcut. And here's the shortcut. My vertex is, if I look at this number, see right here it says plus 3. If I just think of the opposite of that, you know, so I can take this minus sign into account. So what's the opposite of plus 3? It's negative 3, right? And then, so this is, you take the opposite of this one, and this stays the same. So there's my vertex. My vertex is at negative 3, 1. Okay? I mean, let's go back up here. See here, you have a plus 2. That's a minus 2. Here you have a minus 5. That's a positive 5. Here's a plus 3. That's a minus 3. So one of the ways you can kind of, you know, forget about this negative sign here in the original formula is to just take the opposite of this number right here, okay, write it down, and then whatever's on the end over here is your y value. Now remember, on this problem right here, there was nothing written, so I had to put a plus 0 there. That always gets people confused. And one last thing, my line of symmetry on this problem is x equals negative 3. Okay, now I'm going to do another video. You know what, I might as well just continue here. Let me just continue, because I'm already at 13 minutes, so let me continue. Let's take a look at a problem. They're going to ask you to graph. That's what we're actually leading up to. So let's take a problem like something like this. G of x equals 1/2 x minus 4 squared. Okay? And we're going to graph this. Okay? That's my only directions. It just says to graph. So if I want to graph this, one of the most important parts is to find the vertex, right? And this is in vertex form. It's not in standard form. It's in vertex form. So my vertex, it's actually kind of easy, because we don't have to use the formula that we used before, like yesterday when we used x equals negative b over 2a. All we got to do is look right here, and you say, okay, there's a minus 4. What's the opposite of that? Positive 4. Now, what's over here? This is h, k is over here. What's over here? There isn't anything over here. So that's like plus 0. So I'm going to put a 0 right there. So my vertex is 4, 0. And what's my line of symmetry? My line of symmetry is x equals 4, right? Okay, so now let's graph this thing. Now, in order to graph it, you have to do what we've been doing, okay? And what we've been doing is we've been picking numbers and putting them in the table, right? So let's take a look here. Unfortunately, this part doesn't change, but we're going to make this as easy as possible here. All right, so let's think about this. My axis of symmetry is at 4, right? So you can either pick two numbers that are higher than that or two numbers that are lower than that, just like we did before. What's a number that's lower than 4? Probably 3, right? Or we can pick 2. I'm gonna try 2, okay? Let's try 2. Let's take 2 and we're gonna put it in this problem wherever we see the x, right? One way to write this, you could say g of 2 equals 1/2. Now don't write an x, put a 2 minus 4 squared, right? So do what's in the parentheses first. What's 2 minus 4? 2 minus 4 is -2, right? And then what you have to do is square the -2. What's -2 squared? -2 squared is 4, right? And then 4 times 1/2. What's 4 times 1/2? 4 times 1/2 is 2, right? So g of 2 is 2. So basically, when you put in a 2 came out, right? So let's take a look and let's see what we can do here. We're going to try to graph this thing. I got some graph paper here. Ooh, that's not very good. And let's take a look and see how this comes out. So the first thing you want to do is you want to graph the vertex. It's at 4, 0. So that's 4 to the right, 1, 2, 3, 4. And you don't go up any, right? It's 4 to the right and 0 up. Now, this says here, I have another point at 2, 2. So if I went 2 to the right and 2 up, that would be right there. And remember that you have a line of symmetry. My line of symmetry is right here, right? And remember, a line of symmetry cuts the parabola in half. So if this is 2 to the left, I have another point 2 to the right. All right? So, you can already see the shape of my parabola, right? Now, some people like kind of stop there, but I'm going to try another point. I'm going to try, let's try to put in a 1 and see what happens if we put a 1 in. And I'll try to make this a little quicker, okay? So if I put a 1 in here, I'm not going to write this I'm not going to write g of 1. I'm just going to put a 1 in this problem, okay? So it's like 1/2 times 1 minus 4 squared, okay? So what's 1 minus 4? 1 minus 4 is -3. -3 squared is 9, right? What's 9 times 1/2? That's 9 halves. That's 4.5, right? So when I put in a 1, I got a 4.5 out. So if I go 1 to the right and 4.5 up, 1, 2, 3, 4, 1, 2, 3, 4.5. That's right there. And then if I copy this 1, 2, 3 on this side, it looks like that. And as you can see, I have a nice U-shaped parabola, right? Now, in your book, it's going to ask you to compare it to the parent graph, okay? And the parent graph, if you guys remember, it starts at 0, 0. Remember, the parent graph is y equals x squared. So if I put a 1 in here, 1 squared is 1, so that's 1, 1. And remember, you copy it on the other side. If I put a 2 in here, what happens when you square 2? You get 4. So that's 2 to the right, 4 up. 1, 2, 3, 4. Wait, 1, 2, 3, 4. That's right here. And if I copy that on the other side, you get that. So my parent graph kind of looks like this. And if I compare these two, what would you say? Well, we have a horizontal translation, 4 units right. Basically, the graph moved to the right. And also, you see this half right here? That this got a little wider, okay? So that is a shrink. You have a shrink by a factor of 1/2. Okay? That's basically what we're going to do today. The graphing part's the most important part, and we'll work a little bit more on that. Alrighty? Hope that helps.